Okay, matrices. This is a lot of the stuff on matrices you would have learned in pre-calc. Today is easy. Tomorrow is pre-calc. Thursday is new stuff and gets a little crazy. Next week is the really tough week on matrices. So this is, something we can represent with a matrix. The book will use curved brackets. When I write a matrix, I will put them like this. Okay. So yeah, the book uses curved brackets probably because no, the brackets. I like that better because it's something different. It does can't be confused.
It's in my brain for the last like 3 years now. So
Perfect. So yeah, they'll accept that. Matrix multiplication shares some, but not all the properties of multiplication. Matrix multiplication is not commutative.
can't switch.
You cannot switch the order. You can, however, switch the grouping. It is associative. So as long as you keep them in the same order, which ones you multiply first. So say you had matrix A, we're going to use capital letters to represent. You can do that. You can multiply A times B and then multiply that by C. Or you can do multiply B times C and then multiply it by A, as long as you left multiply. So we're going to be talking about right and left multiply.
It's like a two
But
by
yeah,
three and a 3 by 1.
yes. So left multiply means I'm multiplying by it on the left side on both sides. So you can multiply both sides by a matrix, but it has to be the same side of the thing that you're multiplying by. And that's going to come up. That was one that Jordy's like, wait, what? We have to do this. It matters suddenly. Okay, order of a matrix. M by N, rows by columns. So what's the order of this one?
Uh,
2 by 3. Um, Next thing, B2, 3. Row 2, column 3 is -15. This notation works really well if you don't have matrices with double-digit rows and columns. You'll probably never get one on a test that does. Yeah. So unless you're doing Jackson's IA, you're probably fine. Okay, matrix equality. So we can find X and Y by writing equations here. X squared plus 1 equals -17y. 2 does equal 2 here. Y does equal y. Those aren't particularly helpful. But this one is really helpful. X equals 4. So now I can plug that in. 4 squared plus 1 equals -17y. Y equals -1.
Substituted for X.
So things line up spot to spot. And since they had one that was simply x equals 4, that became really easy.
But it was like an equation.
But yeah, I was expecting when I saw it to have a system of equations. The order of A is 2 by 8, and the order of B is 2 by 2x squared. Find x. X is 2. Wait, if A equals B, yep, that means it's 2 by 8. So 2x squared equals 8. X has to equal plus or minus 2, but really just positive 2.
2x.
Because if they're equal matrices, the orders have to be the same. And you're like, oh, yeah, that section was easy. Addition, subtraction, and multiplication by a scalar. Addition of matrices, you just add the parts that are in the same spot. Subtraction, you subtract them. I don't believe in subtracting, I add negatives. So I would go through and negate B if I have A minus B. Distribute the negative and add. I just have a lot less mistakes. So the matrix for the final price, A is describes the price of product I in store J. Each of the stores is running a sale. Matrix B shows the amount each product is discounted. So find the final price is actually A minus B, which is plus, and I'm just going to make them all negative. Oh. And I'm writing this out just in case you need it looking back. 21.3 minus 0.5 is 20.8. 22.5 minus 1.4. 21.1. 45 minus 1.4. 43.6.
Oh, it's 0.4, not 0.5.
Yeah.
I can do subtraction.
Yeah, you just have to be awake enough. 15.9 minus 3 is 12.9, and that one's really discounted. 14.5 minus 1 is 13.5. And there's our matrix. A, B, and C. I'm going to start by just, writing some things out. 2 plus A equals 2B. 3 minus 1 does equal 2. A plus 1 plus 2 equals B. Okay, I'm going to solve for A and B now.
It's kind of the same as the other one.
But now they've got addition. And I actually have to, I'm going to need to get C later too. Oh, C equals 4. Oh no, it equals 4 plus A. Okay. Well, I'm going to get this 2 plus A equals 2A plus 6 minus A. A equals negative 4. B equals negative 1. And C equals 0. Does that work for this? -4 plus 0. Yeah, that works.
Equations for the
Negative
amount of
2 plus
variables.
1. Yeah,
Don't turn everything into this.
I didn't need to, no.
For each.
So as soon as I got two equations with with just those two variables, I used them to solve.
Okay, because we don't need C for the top row, so we can figure out what A and B are.
And I didn't use the middle one, like 3 minus 1 equals 2.
Now A, we know C.
Yeah, once we know A, we know C. So I didn't write, I did go back and check though that this worked. And, oh wait, A0A. I checked that this worked as well. So I checked them in the others, but I didn't need to write them to solve. Yeah, don't do more work than you need to, because you don't have time. Multiplication by a scalar is just like distributing. So looking at this one, the scalar is just a number. Yeah. Distribute to all things in the matrix. So if all factories are required to, if this is toxic emissions shown by two factories are shown in a matrix where AI represents the amount of toxin I released by factory J. So there's two different toxins, two different factories. Factories are required to reduce their emission of all toxins by 10%. What is my scalar that I need to multiply by?
Increase or reduce?
Reduce by 10%. 0.9.
I don't know why they'd be required to increase.
Yeah, hopefully never that. Hopefully that's never the case. Whether you're an environmentalist or not, you should never be looking for increased toxins. If you no matter what your political stance is, you shouldn't be requiring people to increase toxins. So yeah, I'm just going to open this up and let it show us what that equals. Yay, tough. Okay, given that this, find values of k, x, and y. So I've got kx squared minus 2 equals -2y plus 1. I've got -2k equals x minus 1. Sounds a little more promising. It's only got two variables. Oh, the next one, 3k equals -x. Okay, let's use these to solve.
What? Where are we getting K from?
K is multiplied by those. So I'm going to use these to solve for x and k. And then, no, I'll use the last one. 2ky equals -10. So this is -3k is equal to x. K equals -1. -3x equals 3. Using that one. Then I've got -2 times -1. Y equals -10. 2y equals -10. Y equals -5. Again, nothing too bad there. They get +5. Oh, I'm a dope. There was no negative there. There is a negative there. That becomes positive. Yes, sometimes I make dopey mistakes, especially in the morning. Okay, that's today's lesson.